Lesson 15 is another huge lesson. We're going to be working on some graphing, but we're going to add d equals r times t to our playbook. Let's get started. Here, we're going to be looking at 3 different bicyclists: Bicyclist A, Bicyclist B, and Bicyclist C. Bicyclist A is going 5 miles per hour, B is going 10 miles per hour, and C is going 15 miles per hour. And we'll see how these 3 different bicyclists look on our graph. A says, at 5 miles per hour, how far will a bicyclist go in 4 hours? Use d equals r times t. So I'll write down my formula. D equals r times t. Next line, the rate is 5 miles per hour. So write down 5 miles per hour. Times, the time is 4 hours. So write down 4 hours. Immediately, your mind should see that you can cancel out hours and hours. Now just take care of the numbers, then take care of the units. 5 times 4 is 20. Take care of the units, and that's miles. So here we have 20 miles in 4 hours. Let's go ahead and graph Bicyclist A. Here's our graph, and here on the bottom, this is known as the x-axis. So I'll write down x-axis. And here, this is known as the y-axis. So I'll write down y-axis. Going across the x-axis, we're measuring time. So I'll write down time. And in this example, we're measuring time using hours. So I'll write h in the parentheses. Along the y-axis, we are measuring distance. So I'll write it down. And how are we measuring distance? We are using miles. Write it down. So in problem A, in 4 hours, the bicyclist went 20 miles. So let's go ahead and put that into the graph. Here's 4 hours, and the bicyclist went 20 miles right up here. I'll put a little point there. And also keep in mind that at 0 hours, the bicyclist had not gone anywhere. So I'll write a point at 0, 0. Then I'll use a straight edge to connect these 2 dots. So here is my ruler. Touch this point, touch it with my ruler, and adjust. And now let's go ahead and draw this line. And this is Bicyclist A. Bicyclist A was traveling at 5 miles per hour. So I'll write down 5 miles per hour. Let's move on to Bicyclist B. At 10 miles per hour, how far will a bicyclist go in 4 hours? So it's the same 4 hours as in this problem. Use d equals r times t. D equals r times t. Next line. The rate is 10 miles per hour. Here is 10 miles per hour times, the time is 4 hours. 4 hours. Immediately, you can see that you can cancel hours and hours. And now take care of the numbers, then take care of the units. Take care of the numbers. 10 times 4 is 40. Take care of the units, miles. Circle your answer. 4 hours, 40 miles. Let's go ahead and graph that. Here's 4 hours, 40 miles is up here. So draw a dot right at that point. And this bicyclist also started at 0. So we'll connect these 2 dots. Draw the line. And this is Bicyclist B, who was traveling at 10 miles per hour. Last one, let's do Bicyclist C. At 15 miles per hour, how far will a bicyclist go in 4 hours? Use D equals R times T. Here's D equals R times T. Next line. The rate is 15 miles per hour. 15 miles per hour times, the time is 4 hours. So write 4 hours. Right away, cancel hours and hours. Next line, take care of the numbers. That's 60. Take care of the units, is miles. Circle your answer. 60 miles in 4 hours. So let's go ahead and put that onto the graph. Here's 4 hours, and the bicyclist went 60 miles right up here. This bicyclist also started at 0, so let's connect those two dots. There's the line. And this was Bicyclist C, who was traveling 15 miles per hour. And as you can see here, Bicyclist A was traveling 5 miles per hour. Bicyclist B was traveling 10 miles per hour. And Bicyclist C was traveling 15 miles per hour. So an important concept for students to understand is that the faster the bicyclist is traveling, the steeper the line gets. Here's 5 miles per hour, 10 miles per hour gets steeper, and 15 miles per hour gets steeper. Now that we've drawn our 3 lines, we can start to make some major connections to algebra. Take a look. Here we have bicyclists A, B, and C. And where did we get the information that we needed to draw these lines? And it all came from this little formula right here. D equals R times T. So we used that once, twice, and 3 times. So I'll go ahead and box them. And just remember, D equals R times T is just a proportion in disguise, just like we learned in lesson 13. So take a look at bicyclist A. And what formula did we use to come up with this line? We use D equals R times T. So I'll go ahead and write it down. D equals R times T. And here, notice that bicyclist A was going 5 miles per hour. That was the rate. So instead of writing D equals R times T, since I know the rate was 5 miles per hour, I'm going to write down D equals 5T, because 5 miles per hour was the rate. And here's how you can use that to get additional information from the graph. Let's say you're interested in the distance that the bicyclist has traveled. Just look at the time and multiply it by 5, and that'll give you the answer. So let's say the time that I'm interested in is 7 hours. Where will the bicyclist be in 7 hours? Take 7, multiply it by 5, and that gives me 35 for the distance. Let's see if that's true. So here is 7 hours. I'll go up until I hit bicyclist A, right here. And now when I go to the left, I can see for a fact that 35 is the value for the distance. Now we can take this connection and go even further. Take a look at D for distance. And what axis is it on? Is it on the y-axis or is it on the x-axis? And you can see here that distance is located along the y-axis. So instead of writing D, I'll write y since it's on the y-axis. Bring down the equal sign, bring down the 5, and I'll look at T for time. What axis is time located on? Is it located on the y-axis or is time located on the x-axis? And you can see here, time is located on the x-axis. So I'll write down x right here. And now we have a new formula, y equals 5x. And this explains where this formula comes from. Again, it's just a proportion in disguise. So if the formula for Bicyclist A is y equals 5x, since Bicyclist A was going 5 miles per hour, what's the formula for Bicyclist B, who was going 10 miles per hour? And this would be y equals 10x. So I'll go ahead and box that. And finally, let's look at Bicyclist C. Bicyclist C was going 15 miles per hour, so the formula here is y equals 15x. And that's how everything's connected to each other. This formula here, y equals 5x, came from d equals r times t. And where did d equals r times t come from? That came from our magic formula, a over b equals a over b. So all of these concepts are just proportions in disguise, and it shows how proportions run deep into the heart of algebra.